Hi, everyone. Thank you for attending today's webinar, Using Capital Harness for Contract Manufacturers. My name is Lorena James, and I'm an application engineer focusing on electrical system design and harness engineering. Before joining Oasis, I worked at a wire harness manufacturer in Illinois for 3.5 years, where I dealt firsthand with many of the issues that harness manufacturers face today. I began as a process engineer where I supported manufacturing by creating work instructions, and later led the implementation of Capital Harness XE and other capital tools within our organization. If anyone has any questions that come up throughout the webinar, please feel free to post them in the chat box. As far as audio options, you can choose to use your computer audio or dial in using a phone. From this point on, I will be muting everyone in order to prevent any background noise from coming up. This webinar is hosted by Oasis Sales. We have been a premier EDA partner with Mentor Graphics, a Siemens business, for over 20 years. If you have any questions or would like more information on any of our other software solutions, please feel free to reach out to me and I would be happy to help. As you can see, Oasis provides a total solution for enterprise-level EDA and cabling solutions. Today, we'll be discussing tools for wire harness design, which Oasis is known across the industries as the leading implementation expert in this space. We provide 3 solutions for wire harness design. If you attended our previous webinar, it focused on our Visa solution. Today's webinar will focus on our most advanced tool set, Capital. I'll begin by discussing some of the challenges harness manufacturers face that I'm sure you are all too familiar with. Next, I'll touch on the current process manufacturers follow and those we've seen with our customers prior to implementing our tools. I will follow with where we can improve the current process and how that would look using Capital. Then we will switch over to the tool for a demo on what the Capital approach looks like. Remember to feel free to post questions in the chat window and we'll address those at the end of the webinar. Just about every aspect of our everyday lives depends upon or can interface with electronics that connect to one another through electrical systems. Anything from LED lighting to infotainment centers require more connectivity, which increases the complexity of the wire harness. The richness and quality of data that harness suppliers receive varies from customer to customer and project to project. Often, the merging of wiring and mechanical data is especially problematic. Design objects may be named or represented differently between the CAD design and the wiring diagram. Sometimes they're not even represented at all. Synchronizing is time-consuming and error-prone because harness suppliers are forced to manually merge or re-enter data. It is commonly accepted that the initial harness design represents only about 20% of the effort over the design lifecycle. The remaining 80% is consumed by implementing design changes, which are often both late and urgent. Poor management of design changes causes unnecessary costs and introduces significant quality risk. A manufacturer can ensure the quality of a product by 100% inspecting and/or electrically checking the harness. As harnesses get more complex with constant design changes, the quality check process becomes more time-consuming and thus more costly. It's essential that the harness supplier fully understands the cost of their harness design in terms of both material costs and labor time. Costing errors in quotes can diminish profit margins or even turn them into losses. Again, with increasing complexity, design flow and design changes, and quality changes, improving the price for the customer is just that much harder. Many companies rely on in-house tools like Excel spreadsheets, Visio 2D CAD, and homegrown systems in order to manufacture the harness. Each tool is structured to a very specific build process, and often data must be re-entered to transfer between tools. As you already know, the more times data is re-entered, the more opportunities for error. Design engineers are mainly concerned with the electrical connectivity of the system, not the physical aspects of the harness. Often, they are not knowledgeable enough about harness components, and it is then up to the harness supplier to essentially re-engineer the harness to make sure that the correct components are used and are accounted for. The last thing you want is to be in the middle of the first production run and find out that the chosen terminal does not fit the wire. When all you have is a PDF drawing of the harness from your customer, manufacturing quantities like wire lengths and installation totals must be manually added up. The costing engineer might use a spreadsheet to track all the circuits in the harness and then add them all up as segments to get a wire length. In my previous life at a contract manufacturer, we would use the customer's print to build the harness. It would be marked up with additional notes and instructions, but for the most part, the production operators would use it to assemble. With hundreds of customers, each with their own drawing formats, the operators had to adapt to a new format every time. New hires would take longer to get up to speed, and it would be particularly disrupting when a seasoned employee left the company. One valuable improvement a harness manufacturer can make is to adopt a common harness design tool across the entire business. Not doing so can lead to less lean, less flexible organizations with additional overhead costs. By adopting one common tool, it would allow the manufacturer to make maximum reuse of the harness design data and would make for an efficient, low-risk process. Moreover, using a tool designed to be flexible and with the wire industry in mind, the manufacturer can adjust the tool's automated processes, reports, and graphical outputs. An example of such tool is Capital Harness. Let's take a look at what the manufacturing process would look like using Capital. You start by streamlining the way you gather connectivity data. Once you have that, rather than having to refer to the manufacturer specifications to verify component specs, you can use integrated libraries that will verify component choices for you. I talked about manually calculating wire length. Why not automate this process for quick and accurate values? Like in my previous life, instead of using marked up customer prints, create a one-to-one harness print that operators can build on. Finally, in order to get build data down to the production floor, automatically generate all of the manufacturing reports like BOMs, wire cut lists, installation lists, etc. Rather than exchanging marked up prints every time changes are made, Capital's wiring tool allows manufacturers to work collaboratively with customers using native Capital data. They can exchange design files if the customer is also using Capital, or the manufacturer can create the wire and print. Once completed, the connectivity data is synchronized to the harness layout without having to do any data entry or file exchange. Something I know all too well is that harness manufacturers receive harness data in a variety of ways. Most of the time, it is a PDF drawing of the harness that the costing engineers must extrapolate from. Instead of creating an Excel circuit listing and then remanipulating that data over and over, this list can be imported into Capital and any further manual data manipulation can be eliminated. The connectivity data merges with the harness layout and results in a connected design that engineers can continue adding to. Through the use of Capital's integrated library, a harness manufacturer can add automation to the component validation process. Once the connector part number is selected, the tool will add any mandatory accessory components like back shells and locks. This eliminates the need to repeatedly refer back to the manufacturer specs to check if you are missing a component or if they are compatible. Like accessory components, there usually is more than one option for cavity components. With Capital, you can associate each of these to the appropriate connector. For example, for terminals, based on the wire specification, The system will select the correct terminal. If there are multiple terminals that meet the wire spec, a priority hierarchy can be assigned. We can speed up the design process by allowing Capital to automatically assign part numbers to the design components. In the connectivity data spreadsheet, instead of dictating the wire part number, simply add the material spec, gauge, and color. Once imported, the system will match the spec to the library and add the part number for you. You can also automatically select part numbers for multi-core splices, heat shrink sleeves, spot tape, insulation tubes, etc. Picture not having to manually calculate your wire cut length. Once the connectivity data is added to the harness layout, Capital will calculate these values automatically. Anytime there is a length change, you can simply select to recalculate and the totals will be updated. The wire CSA and diameter are used to determine bundle width. Once calculated, Capital can also automatically select the insulation tube based on the width of the bundle. The system uses rules and constraints defined by the user to automatically place splices. If you're placing center strip splices, the center strip distances can also be calculated. Harness weight is very important, especially when the harness is going into any sort of a vehicle. The tool takes the weight for each component to get a total harness weight. Once these values are calculated, you can generate reports for manufacturing to use. Anytime there is a change to the design, the harness is reprocessed and updated values will be recalculated. After implementing Capital at my previous job, we no longer had to use marked up customer prints on our production floor. Instead, we printed the form board drawings for the operators to build on. Because all the bundles are lengthened to their actual length, the engineers then added arcs and bends to make the harness fit the board constraints that it was to be built on. To eliminate any build errors and to improve efficiency, form board fixtures can also be added to the print. The placement of the fixtures can also be automated using rules and constraints. A new feature in the latest Capital release is the ability to merge form boards. Using merged form boards, manufacturing engineers can design different but very similar harnesses on the same print. This frees up available factory space and other resources. Off the bat, the tool has built-in reports that you can use in manufacturing. There is no need to tally up component usage in order to create a BOM. Instead, generate a BOM report, and anytime there are any changes, simply generate a new one. Along with the tool built-in reports, Oasis has created additional ones per our customer request. They were created using Java and are a more detailed version of the built-in report. If none of these meet your needs, there is a report builder tool where you can create a report template that you can use over and over. Aside from the exportable reports, you can place tables within the harness print. These are also updated real-time as you make changes. In the demo, we will cover how to streamline the sharing of connectivity data, how to create a full bill of material using the integrated libraries, how to ensure you have a manufacturing-ready design using design rule checks, how to automatically calculate and report manufacturing quantities, and how to have multiple drawing formats using styling. Once we are done, we'll wrap up and have a Q&A at the end. All right, so now I'll go ahead and switch over to the tool. All right, I'm starting off in our Capital Logic tool with an example of a wiring design. I won't be covering how to draw a wiring diagram, as this collaborative effort does not represent the majority of harness manufacturers, but I will show how the wiring data from Capital Logic can be synchronized to the harness layout. If you are able to work collaboratively with your customers, you might be able to contribute to the wiring design efforts. This is definitely an added service that your customer would appreciate and one you can benefit from by knowing immediately when changes happen. Capital can allow you to work towards this kind of relationship with your customers. So once the wiring design is completed, you merge or you sync the wiring information to the harness layout, and the link occurs by identifying the harness attribute. So by identifying which harness this wiring information is going to be linked to, in this case, it is the name of the harness, the connectivity will be merged in our capital XC tool. So I'm going to go ahead and switch over to that. All right, so here we have a harness structure for a harness. We don't have any components. We just have bundles. I mean, this one still happens to have insulation on it. We make sure that the bundles are named the connector names, for example, from our logic design. So this kind of structure you could import from an MCAD. A lot of the times that information doesn't come with electrical information anyway, or you can simply draw it. And as far as drawing it, right, it's as simple as drawing a line. This is a not to scale environment, right? So I can go ahead and change that dimension. And the bundle length will stay the same here. So I'm going to go ahead and synchronize. Yes, I'll save my changes from the wiring diagram that I had previously shown. Now this is letting me know that I have it open. I didn't make any changes, so that's fine. Obviously, this is letting me know there were no errors. And you can see now that we have component information. So we have splice part numbers assigned. We have connector part numbers, wire part numbers, and of course, any other components. So this would be the method if you're able to work in with native capital data, or you're able to work collaboratively with your customer in designing those wiring diagrams. If that is not the case, which is what I feel happens most of the time, I'm going to go ahead and undo this. And so, I don't think it'll unsynchronize. I'm going to go ahead and remove all of the wires. We'll remove the connector, right? And so here we have associated the splice location. The splice part number is assigned when you bring in that information. So what I'm doing right now is disassociating that splice component with an actual splice part number in the library. And so what I'll be doing now is bringing in the data from an Excel sheet that uses an Excel macro to convert the data into XML in order to be able to import into XC. Right, so imagine you have your bundle structure. This could have been imported from an MCAD system, or you could have drawn it yourself. I'm going to switch over to the Excel sheet that I mentioned. And so here you can see that we have a from to data sheet. So you'll identify the wire part number, and now I have here whatever is highlighted red is what's mandatory. Anything else is essentially optional. So we have to obviously identify the wire name, wire color, gauge, and type, as well as the from location. So that could be a connector, a ring terminal, a splice, the cavity information, and the same thing, the to information. So again, it could be a connector. Here we have some splices, and to for cavity information. And we have this marked as, for example, a splice. You mark it as cavity X because you don't really know if the wire is going to be coming in from the left or from the right. And so you let the system determine that for you. So by X is, we'll just essentially send it to the center. And when we go ahead and process our harness, we will identify which side is coming into that splice too. And so this Excel sheet, right, here's a setup tab for it, identifying how the information is mapped to the component attributes within Capital. And so this generates, by running this project XML macro, it goes ahead and generates an XML file, which I already generated. So I'm going to go ahead and switch over to Capital Harness XC. And I'm going to go ahead and bridge in my XML file. So here you can see I have it ready to go. Go ahead and import. It generates a bridge report that lets me know if there were any errors. And just like the synchronization, you see that the component information comes in. And as far as graphics here, I talked about styling a little bit in the presentation. So all of the information that is reported out, as well as graphics like the connector graphics, or as we call them in Capital, symbols. The symbols can be customized by style set. So you could have one style set that has these enlarged insertion views, and perhaps some auxiliary sheets with more enlarged insertion views, or I have another harness that has a different style set that's styled a little bit different. So the information contained, for example, within the tables, that's controlled with styling. So if I go into the style set and I look at my tables, I can control what information is shown. So I could show, right, the cavity number, customer part number, supplier part number, or I could uncheck it. So leave the visible check mark unchecked or box unchecked, and that will not be shown in the table. And we can see that components were associated to the library components easily by looking on our left browser and seeing these orange check marks. So at this point, right, my connectors, I put in the connector part number in my from to Excel sheet. So it mapped it to the library component in the library. And so I get this orange check mark. I only inputted the attributes for the wires. And so I still have to go ahead and let the system auto select those wire part numbers for me based on the attributes that I selected. We also talked about validating the components. So if I go into a connector, for example, C1, and I go into cavity component management, I can see that I don't have any cavity components inside of this connector yet. This is auto-populated. It searches in the library to look for the terminals or seals or plugs that match the wire specs and assigns them to the connector. So actually, before I do that, I'm going to go ahead and process my harness. Now, by processing, I'm actually going ahead and selecting all part numbers and running my cavity component management at the same time. So then we'll have wire part numbers assigned, and then the system will have something to look at for assigning the terminal. So we go ahead, do our harness engineering. Again, right, calculate wire multiplier length. So we only have distances right now with the bundles. It'll calculate a length for a cut length for the wire. Selecting my component part number. Go ahead and finish. And now if we look on the left side, we see that we have orange check marks at the wires, which means that we have wire part numbers. Now, I don't know if you noticed, but our table information, our tables got bigger, and that's because now we have terminal information within the connector. If I go into my cavity component management, actually I wanted to look at connector C1. I look at connector C1, I can select terminals by, I guess, different priorities. So first off, you can select something like a material driver. So if you want, only gold terminals, only silver plated terminals, this would be a good place, or this would be the place to assign that. And you could assign this both at the cavity component management level or at the connector. If you look at the connector attributes, we could have a terminal material driver. So if we go back to cavity component management, the way these terminals were selected, I talked about being able to set up a hierarchy, right? So up here we have the terminals that match the wire specifications that we had assigned to that cavity. We have here a factor. So we have a factor of 2 and a factor of 0. So the higher the factor, the higher the priority. So this second terminal, this 4271 terminal, was chosen over the other one because it had a higher factor. These down here are also terminals that fit that connector, but based on the wire specs that we had given that cavity, they didn't fit. So then they're down here in the non-matching wire specification list. So when validating your customer's choices, right, so you'll let the system auto-select the terminals based on your manufacturing processes. For example, single terminals, loose piece terminals versus the real terminals. You'd obviously, if you have an applicator, you would give the real terminal a higher factor. So your customer chose the correct terminal, but it was the single loose piece, then you'd be able to auto-select the correct one here without having to manually go through the whole thing. I'm going to go ahead and cancel. So by unchecking it, it would mean that I am not going to let the system select the terminals for me. Go ahead and cancel. Now, one other thing that our processing did was auto-calculate the wire cut length. So there's a lot of factors that go into calculating the wire length. First off, obviously, the bundle length. Next, we can select criteria, or we can set different specification on how the wire is going to be calculated. So, and you could assign this at the project level, at the system level. So if we go ahead and open project preferences, go to my harness engineering. In order to calculate the wire length, I could go ahead and add something like an add-on per junction. So anytime that a wire crosses a junction, I would add 3 millimeters. We can do an overall percentage add-on. So depending on what the wire length is, always add 1% or 2%. You set a maximum value for those. And then other specs that you would select. So whenever, if there isn't a splice strip length assigned within the library, okay, we're going to go ahead and just have this one in the system. So it'll use this strip length in case there's one not assigned in the library. So as far as wire calculations, you can get more granular depending on what your internal process for cutting wire is at your manufacturing facility. Something else that is taken into account is if I go into my design, I can identify what I am dimensioning to. So I could be dimensioning to the front, to the back, or for example, tip of the terminal, or where the wire ends inside of the connector. For example, if we're measuring to the back of the connector, then we would want to know how much of the wire is inside of the connector, because we need to account for that. Otherwise, our cut length will probably be too short. So that kind of information is stored within the add-ons and knockoffs. So if it's measuring to the back, then it'll add the add-on value. If you're measuring to the front of the connector, then it'll take off that knockoff value. All right. So we would also, so if we went ahead, we added our cavity components, go ahead and add in any installation. Again, the system you can add an installation by simply selecting the start and the end, or just the bundle itself. You could add, tape, tubes. If I could have the system select a tube for me based on the bundle width and certain attributes that I assigned in here. So it's, if I wanted a slit tube, I want to make sure that it's black. I would select the criteria in order to filter, and then based on the bundle width and whatever is inside of my library, the system would auto select that for me. So now assume we have all of our installations added. I'm actually going to go ahead and switch over to this not to scale design. Actually, that's the same. There we go. Right, so we have a completed design. I'm going to go ahead and run my design roll checks just to make sure that this harness is manufacturable. And things that it'll check for, so unconnected wire, invalid components, for example, for the library. It'll check to make sure that the part number is not obsolete or invalid if changes have been made since you first imported the information. Empty splices, cavity seal does not fit the wire. So pretty much anything and everything that you would want to check for, these can be prioritized. So if it's something that is not a big deal, so right now, a blank terminal material driver. I didn't set a terminal material driver on any of these. I actually let the system auto select based on the wire specs. So I unchecked that design rule check because all of my terminals have a blank material driver. but we can also set the change whether this should be a hard stop kind of check, or if it should be something more like a warning or just a flag to let you know. So I'm going to go ahead and run. And so I actually have a couple that have no terminal on connector 5. So let's find out what is going on there. So if I uncheck, it just means that all of my wires that, or the wire specs that I selected for this cavity at this connector do not fit the wire specification set for these 3 terminals that can be used with that connector. So if I was validating this as a harness manufacturer, one, whether my customer selected a terminal or if they left that choice up to us, we can go into the library and double check that perhaps this 1376/7046 terminal, we have validated that it actually fits this, let's see, where can we see this 7048, so this wire specification, so 7048.3. If we're looking at our wires, right, so this is, type FLRA, it's a 22 gauge wire, and we have validated that that terminal actually does fit this wire. There are crimp specs validating that. So then we need to change the wires that fit the terminal inside of the library. In retrospect, if that's not the case and you just don't have that terminal in your library, then this just means that you'll need to look for a terminal that does fit that wire, and it'll be a new purchase for your organization. So it'll be a new terminal that needs to be used. And so again, something like a splice part number has not been assigned, and actually I did make sure that those weren't assigned because I didn't have the wire specs just yet. So you can see that these will come up, and ideally what you want to see is that this design will not have these design rule checks coming off. So say we went ahead, validated these, we then came up with a clean slate. What we would do is create a form board design. Again, the form board design, if I go ahead and create one here, so it would be a new diagram. We'd go diagram 4. Again, style sets, you can have as many as you want, and it'll depend on the different kind of formatting you want for your different kinds of design. I'm going to do a metric form board. I'm going to do full scale, and we're going to reference the diagram, right? The not to scale diagram. I already have a form board, but if you were doing this from scratch, you'd have a not to scale, and now you're creating your first form board diagram. Let me go ahead and open that up. And so here, right, you can see the difference where in this one, I already went ahead and added my arcs, the side sheet that I needed that I have to work with in order to build this harness. We can go ahead and add form board fixtures. So then after creating your form board diagram, you'd be able to run your report, right? So we talked about generating these reports for manufacturing to use. So we have something like a BOM report. Now again, the ones I'm pulling up are the Oasis ones. Really the difference is we just pull in almost every attribute that you can think of in the library. So aside from the internal part number, we're bringing in customer, supplier, description, all of the attributes that you can populate within the library. So that's a BOM report. We can do something like a wireless. So that would be, for example, the one that a system wireless, right? Wire name, length, terminal information. So this could be enough to feed into a cutting machine. So you would, this is generated as an HTML, but easily can transfer into an Excel sheet that then can be imported into your cutting machine program. We looked at report, and I think that's about all we have time for. So we'll go ahead and switch back to the PowerPoint. All right. Capital Logic and Capital Harness XE are only two of the wire harness applications in the Capital Suite. In addition to these, we have Capital Modular XE, which allows you to break down large complex harnesses into manageable subassemblies. Capital TVM produces detailed labor and material costs. And Capital Workbooks automatically generates the work instructions needed to build the harness. We will be discussing these in future webinars, so stay tuned. Oasis offers 3 tiers of products: Capital, Thesis, and Solid Edge Electrical. These incorporate the key components of building a wire harness system involving processes, collaboration, smart data, and documentation. Our deep understanding of the industry enables us to provide the right software products and services that solve any complex design challenge. As you can see, implementing Capital as your common harness design tool across your whole business can benefit your organization tremendously. For one, it gives you the opportunity to work collaboratively with your customers. You can speed up the quoting process, first production run, and revision implementation time simply by being able to reuse data. Not having to re-enter it will also lead to significant quality improvements. Finally, having consistent documentation will decrease training time for new hires, as they will only need to learn one drawing format at a time. Our team will guide you through every step of the way to ensure a successful deployment. As part of our Wire Harness Quick Start program, we will work with you and your team on a guided pilot project. We have found that by replicating an existing project, users quickly grasp how to use the tool. It is also critical in ensuring the new process is seamlessly merged within your organization's existing processes. This method provides the best path to a successful implementation. Today, we discussed how our Capital tool can help your organization become more efficient and stay competitive in the wire harness industry. It's important to note that the software is only as smart as the user. The proper implementation, customization, and training is key to a successful deployment, just like any other technology. Oasis provides services that are tailored to solve the challenges that companies across the world face in their day-to-day work. Our goal is to help companies bring the most advanced electrical, network, and harness technologies from concept through design, production, and into service. Here's a list of the other domains that we specialize in: If you have any interest in finding out more, please reach out to myself or anyone at Oasis. I want to thank you for your time and attention today. Let us know how we can help. I invite you to save the date for our next webinar on March 28th. We will be covering additional capital applications that allow you to automatically generate accurate harness costs and work instructions. You can visit our website at www.oasissales.com to register. Now we will open up the floor to Q&A. So let's see if there were any that came up throughout the webinar. All right. Okay. See, we have one. So they generate a sleeve report, select the correct sleeve size, and test it to be printed. Yes, you definitely can. All right, so we'll switch over to XC. Let's see. Okay, so first off, all right, I don't have a partner. Let's try this again. So I'm gonna select my splice part numbers. Now this is right, so the way I did it previously was through processing. I must have not had the select splice part numbers checkbox checked, because I do believe I have them in the library. There we go. Okay. So we do have splice part numbers. So as far as adding, for example, a heat shrink sleeve to a splice and having it auto select, I can go into my splice attributes and I can select, for example, right now I have an insulation type of none. I can select to have a heat shrink sleeve. And so then go ahead, select that. I haven't done any processing, so I'm going to go ahead and just do it, you know, the manual or just one at a time kind of way. Select my heat shrink sleeve part numbers. So here we have a heat shrink sleeve that was added to the splice based on the splice CSA specs for that splice, and so and then automatically we have this additional component that comes up for that splice, and then we have, you know, one column that says is it mandatory? No, because I didn't assign it as a mandatory component. It's just one that I just now added. So as far as selecting heat shrink sleeve, let's see, what was the question? Yes, so heat shrink sleeve. Now, let's see, information for labels. So yes, a label could be another additional component to the splice. I believe I do have a label in this design, yes. So here, for example, we have a harness ID label. So depending on the kind of information that needs to be printed, then we could feed that through a report. So this is a harness ID label. If I needed to create, if I needed to print a label with, say, the harness part number, the harness revision, then those are attributes that are, I guess you can say, hard-coded. And so we can create a report that taps into the information in those attributes, the harness ID or the harness part number or the harness revision, and then generate a report that then can be fed to your printing machines with the information that needs to be printed on the label. All right, is there any other questions? So the plugin tool and embedded in Excel, yes, it is. So if I bring that up, we have, right, so we have this setup tab that maps the data column to what they would be, what the attribute that they would match in Harness XD. So we have, for example, right, that wire spec, wire color, specific part numbers. So for the connectors, certain ones are mandatory and some are optional. So a short description you don't need to have, but it would populate it in the design if you did decide to put that information in here. So we do have some short descriptions for some of the connectors. If we look at the harness design, those are populated. And well, before I switch over, so we have, right, the built-in Excel macro that will generate this as an XML file to be imported. So if I switch over to the tool, we have here, if you look at the connectors, we should have a description coming in. All right, any other questions? Do we have, is there revision control? Yes, there is revision control, and anytime a new revision is created, the system keeps a history link. So I can create a new revision. So let's look at my design here. And so create revision, right? Go ahead and close my design. So go ahead and create a new revision. It knows that it's under the same design name. My part number, I mean, sometimes new revisions come from your customers and they switch the part number. So you're able to switch that, but in this case, let's say that it's now just going to be revision 3. And so then it lists the new revision under the same design. And then adds it. And so it creates essentially a copy of the previous revision where, right, this is what you're starting off with, and then you can go ahead and make the changes. So if the customer changed the bundle length, changed the connector part number, then you'll go ahead and make those changes. All right. So does the component library provide technical information on the component, like dimensions, current capacity, crimping tools? Yes. So if we take a peek into the library by double clicking in here, we can see that the information contained for this component is specific to the group that it is under. So this connector, right, you would expect to have information on perhaps color, material, add-on and knockoff, like we talked about, number of cavities. Then if we look at something like the housing component or the housing tab, you identify the terminals that fit that connector and any additional components that that might be mandatory. For example, clips, back shelves, locks. And so if we then take a look at, for example, this library, this terminal, I'm sorry. And again, I'm taking a peek into the library. I can't actually edit any of this information. You'd expect the same thing, information on perhaps the material code, but then information like a strip length, right? That wouldn't be relevant to a connector, but it is to a terminal. So you'd have a strip length for a single wire, and then say you have multiple wires terminating at that terminal, then you'd have perhaps a different strip length for that. And then add on and knock off value. and then information on the wire sizes that fit that terminal. So this is, right, everything is relevant to the specific type of electrical component that it is, and the information is used to make decisions like choosing a terminal in a wire or in a connector based on the wire spec, choosing your insulation, your tubes, your heat shrink sleeves. And then as far as, actually, let's go in the terminal. So something like your crimping tools. So that is actually something that we did in at my previous job, right? We identified the crimping tool needed inside of the properties tab. So these are properties that you could add to any component, and this would be just additional information that's relevant to you and to your organization. So things like the applicator, right? So then you go ahead, you add this this property, and then you populate it with your applicator code, your hand crimp code, and then any other, you can create properties for any other information that you might need. And so then same thing, these properties can be accessed through reports and queries and rules. So if we access those through a report, right, if you print out a BOM report and you have all of your terminals listed, and then you list both, say, the applicator code and the hand crimp code, if you see one that it's missing, then that means you might not be tooled for this terminal at this manufacturing site. And so that would be, need to look into purchasing a new tool before committing to this harness. All right, any other questions? Can you do comparisons? Yes, you can do a design compare within the tool. So if we go in here, we go compare, you can select two designs to compare. They don't have to be revisions of each other. They can be two completely different designs and different projects. So we have here, I have, my revision 3. I'll go ahead and maybe compare it to revision 1. And so I don't think I've gone ahead and done any calculations. I might not see many differences. But you'll see here the differences between the two designs, right? You saw there, there's a difference in bundle length. And so then when you go ahead and select on the difference, it will actually take you to the design and highlight it for you. And so this can be exported for you to, say, pass on to your customer and just validate if there was a revision change, they only listed a few changes, or they didn't list any, just to validate with them, hey, these are the differences that we saw, are there any more? Because this is what we caught. All right, any other questions? For access to the recorded webinar. Yes, so this webinar will be available on our YouTube page. It's Oasis Sales, but the link will be available on our website at oasissales.com. So please look out for an email that will have the link and access to that. All right. Well, if there aren't any more questions, I want to thank you for your time, and I hope to see you at our next webinar.